This video covers how to work out all the solutions on your Unit 10 gas law quiz. Be sure that you're looking at your version number because your version number may be in a different order. All of the versions have the same questions but just in a different order. You got points taken off if you didn't share your work. You got points taken off if you didn't put your answer in the boxes. You got points taken off if you didn't put the correct units. And you got points taken off if you didn't use 3 sig figs. These were all directions clearly stated at the beginning of the quiz. In the first section of the quiz, these were all 3 or 4 points each, and all you're doing is converting a 12.9 millimeters of mercury into a different unit. Now, that means that you need a conversion factor. The very first one asked you for torr, but it gave you the conversion factor right there in the question. So you just had to simply put 1 torr and 1 millimeter mercury. And if you divided the millimeters of mercury, you would get those units canceled, and then you would be left with an answer in torr. This is 3 sig figs, and this is the correct units. The second one asks you to convert from millimeters of mercury to atmospheres, and you can do the second one and the third one by using the conversions on your reference chart. 1 atmosphere and 760 millimeters of mercury and 101.3 kilopascals are all equal to each other. Therefore, you can use them as fractions in your conversion. So you're just going to have to remember to put the 760 millimeters of mercury on the bottom. That way the units will cancel. And then you will get the final answer in the units desired. If you type in 12.9 in your calculator and divide it by 760, you're going to get this number. But you need to have 3 sig figs. So you get to have 1, 6, and 9. However, the 7 rounds this up to 1, 7, and 0. So when you write your final answer, your 3 sig figs are your 1 and 7 and 0. This is simply a placeholder, and that is there to identify the decimal. The next one is converting from millimeters of mercury to kilopascals. So we're going to use this conversion right off of our reference table, the millimeters of mercury on the bottom so that they can cancel. And when you type that in your calculator, you're going to get 1.71 something, and so it's going to round up to 1.72 kilopascals. Let's look at the next one. The next one asks if you have the total pressure in a system equal to the partial pressure of nitrogen, partial pressure of oxygen. In this case, they made it easy for you because the pressure of nitrogen is in millimeters of mercury, the pressure of oxygen is in millimeters of mercury, so you can simply add those two together and you will get 759 millimeters of mercury, and that's your answer. 3 sig figs and the correct units. On the next one, it has a word problem with a variety of information in it. So the key thing you want to do is each data point you want to figure out how does it relate to the variables in the problem. And so it says a balloon with a volume of this. So you have the first volume is V1 and a pressure of this. So this is P1. It's then changed so that it has a new pressure, P2. And so it's asking what will the new volume be. So we're looking for V2. So what we need to do here is determine, okay, P1, V1, P2, V2. We need to solve for V2. So we need to determine how to get V2 by himself. Well, since he's being multiplied by P2, we can divide it by P2. And so now we've solved for V2. We simply plug in the correct information for each of the other variables. P1 is 6 liters. P1 is 101 kilopascals. P2 is on the bottom. And if you'll notice, the kilopascals cancel. And so my answer is going to be in liters. And so if you type this in your calculator, you're going to get 6.66 liters of, would be the new volume. All right, let's look at our next page. The next page has, again, a word problem with a variety of information. Now that we have temperatures, we have to remember that all temperatures need to be in Kelvin. So the first thing you're going to do when you start worrying about the temperatures is convert them to Kelvin. So 33 degrees is a hot day, so that's the first temperature. The next information is your volume. So this is your first volume. And then you're going to convert information to a new, or convert the gas to a new temperature. So this is T2. So again, we're going to convert our temperatures into Kelvin by adding 273. And since 273 has infinite sig figs in it, we just keep the same information as whatever we get when we add it. Now we need to rearrange this so that we can find what we're looking for. We're looking for the new volume. Okay, so we're looking for V2 to be by himself. Since he's being divided by T2, we're going to multiply both sides by T2 so that V2 is alone. And then we simply plug in the information for what we have. So V2 is V1 and T2 divided by T1. If you'll notice when you plug in the information correctly, the T2 is here and the T1 is down here. And those units will cancel and my answer will be in the correct units. Now my calculator is going to give me something like 2784.3137 blah 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 blah. But you can only have 3 sig figs. So you need to type in 2780 liters. Let's look at the next one. This is a pressure. This is a temperature. Move this out of the way. So this is the first pressure. This is the first temperature. And it's heated to a new temperature. So this is our second temperature. And then we're going to need to rearrange the formula because you want to know the new pressures. Okay, so this is what we want to have by himself. If you use the little butterfly technique that you may have learned, then you would know P2T1 is equal to T2P1, but we want to get P2 by himself, so we have to divide by T1 so that it can be by himself. Now, don't forget that we need to convert our temperatures into Kelvin, and so these were the correct Kelvin temperature conversions. And then we simply put in our information in the formula that we were given. So we're going to put in P1 in kilopascals, T2 and T1, and again the Kelvin will cancel. My answer is going to be in kilopascals. When I type it in my calculator, I get 286.464527 blah blah blah. I only need 3 sig figs, so my answer is going to be 286 kilopascals. Looking at the next one, this is a pressure. So this is the new pressure and first pressure and first temperature and first volume. And then it's going into a decompression chamber with a new volume. So this is V2 and the new temperature. This is T2. And what is the pressure? So P2 is what we're looking for. Here's our formula. And so we're looking for P2 to be by himself. Now this one's a little trickier. Whatever is being done to P2, you got to rearrange it so that you can get rid of this stuff. V2 is being multiplied, so we're going to divide V2, and that'll get rid of that. T2 is being divided, so we're going to multiply both sides, because whatever you do to one side, you do to the other, and that's what you get. Now let's look at our temperatures need to be converted to Kelvin. You never use a temperature that's not in Kelvin when you're in gas laws. And then we're going to take our formula and simply plug all of the known information into the formula correctly. Notice how the liters will cancel and the Kelvin will cancel, and my answer happens to be in kilopascals. When I type this in my calculator, I get 496.2433 blah 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 blah, but I only need 3 sig figs, and so this is my final answer. Okay, let's look at this one. This one has 2.5 liters of a gas at STP, and we want it to, we're given the conversion actually right here, 22.4 liters in 1 mole. Now the liters need to go down here because we need to be able to cancel liters with liters so that my answer will be in moles. So when you type this in your calculator, you're going to get 111,607 blah 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 blah. I need 3 sig figs. This 6 rounds that 1 up to a 2. If you put 111, it wasn't counted off. It's just not as accurate as 112 moles. So let's look at the last page of our quiz. And this last page starts off with the ideal gas law. And the ideal gas law is here. Pressure times volume of a gas is equal to the number of moles times our ideal gas law constant times temperature. So first you need to identify what these things are. N is moles, so this is N. This is pressure. This is temperature. It needs to be converted to Kelvin, okay? And it asks for what volume. Now, it doesn't give you R, so you have to pick which R you're going to use. The R constants happen to be down here. Now, if you'll notice, the R constants are dependent only on the pressure units. Everything else is the same. This has liters, so does this one and this one. This one has moles, so does that one and that one. All three of them have Kelvin. The only difference between these constants are kilopascals, atmospheres, and millimeters of mercury. Since this is in kilopascals, we're going to use the 8.31. So we need to rearrange it for volume. So we're going to divide both sides by pressure. That way these guys cancel. And so now we're going to plug in all of the information into that formula. So if you do that, N is moles, R is 8.31, and remember R has units. It's liters, kilopascals per mole, and Kelvin. Temperature is here, and then divide by pressure. Notice how the units will cancel. Our moles cancel, our kilopascals cancel, our Kelvin cancels, and I'm left with an answer in liters because the R has a units, so don't forget that. So if I multiply these three numbers and divide it by 98.4, I'm going to get a number that's 13.910804 and so forth. A lot of calculator involvement, but I get 3 sig figs, so I'm going to put this. All right, now we just kind of answered this question just a moment ago. How do you know which gas law constant to use? Well, choose the gas law constant R that matches the given or desired pressure units. Okay, I was looking for this word and this word in your answer. So if you said it just depends on measurement, or it depends on which gas law you're using, or it depends on anything else, you did not get credit. It really only depends on the units of pressure. So we're looking for units of pressure to be in your answer. The last part of the quiz was simply right out of your study guide. And so it had the answers that were listed in your study guide and also in your textbook for the kinetic molecular theory. And it also included the very last one that isn't often included. Most of the time, the kinetic molecular theory only includes the first four, but the fifth one is there. It's just not always given there. All right, be sure to review what you missed so that you can do it for the test. Good luck.